Hi everyone, my name is Shreyanand. I am a data scientist with Red Hat, and today I'll be talking about Prow logs in GCS data. In our continuous integration process, we have several test jobs that run for OpenShift builds. In this notebook, we are going to go over the build logs that we collect from these builds and also other artifacts that are present. I'm going to talk about the data set. I'll give you a brief overview of how that looks. And the first part of the notebook, we will compare the different log files present throughout the archives and quantify how complete and comparable our log data set is from build to build. And in the second part of the notebook, we'll download a sample data set of the events and build logs to perform some initial EDA. So let's dive into it. In the first part, we're importing all the files that are necessary, and then we select a particular tab, which is also a test grid, and then within that tab, we select a particular test job. We do that so we have a narrowed scope, and then we can do our analysis on that particular test job. Let me just go ahead and show you how it actually looks on the web. So this is that particular test job, and we have all these builds. So we can click on one of these and look at all the files present. So we have the buildlog.txt and then other JSON files here, and then we also have the artifacts directory. So we're gonna download this in the notebook environment and then try to analyze it. So we do that using Beautiful Soup. Like what I showed you right now, we get this directory files here, which has these buildlog.txt and artifacts and all the other JSON files. And so we can do that programmatically here. Once we have that, we can start seeing whether this data is complete and if we have any variances in the number of files present. So here we can see that almost all the files have all the files and directories present. So 238 have all these 6 files and directories present. Then some of these would have some missing items. For example, 2 of them have the pod info missing, and 2 of those would have the artifacts missing. But 98% of our records for this job appear to be complete and include the artifact subdirectory. So the artifact subdirectory would also include other important information for analysis. So let's just go into that subdirectory and try to see if we have everything present there as well. So if we look in the artifacts directory, we find that 40% of the artifacts have 6 items and 20% have 7 or 8 items, which means that there is variance here. And if we actually do some value counts and see which files are present, we find these combinations that are there. And what that means is that within a single job, we have less uniformity in the data available. So we can assume that as we move forward, comparing available artifacts across jobs can get worse. So it makes sense to consider looking only at some document across jobs wherever available. So we are looking at one particular document and then try to see if it's how it varies across different builds. So let's go ahead and look at particular build logs and events.json file. So we move to the second part of the notebook where we are collecting this specific files. So here we are using Google Client Storage to get the build logs.txt file, and we get that for all the builds that are there for this job, and then we do some basic analysis on top of that. So this gets counts function retrieves characters, words and lines for a log, and this data frame shows these build logs and the number of characters, words and lines in those logs. And if we do value counts and describe for these, we find that the mean number of lines within the logs is around 722, and the range is from 2 to 21,000. So what that means is that all these logs are varied in the sense some would have as low as 2 lines and some would have as high as 21,000. So that means these logs are quite different in nature, and right, so we would need to account for that when we are doing analysis. So that was the build log.txt. We also looked at the events.json file. So the first thing that we saw was there are 98% builds that have the events.json file, so it's pretty much uniform. Once we get the events.json, we can actually get the event message for the UID, which is pretty much the meat of that particular events.json file. And we can also go and try to do value counts for those messages, and we see that we have messages like started container, place entry point, container image this, and the value counts for those. So in this build data, we saw about 90% builds have the events.json file, and we analyzed all the events that happened for a particular build and found the frequencies of the messages. This can be useful for further analysis, and it can also offer as labels for a machine learning problem. So in this notebook, we try to show how we can retrieve all this data and how the schema of this data looks like. We can do more analysis and come up with interesting machine learning problems from this data. So at the end, we save the build logs and the events file into the repository so that we can easily access this when we are doing advanced analysis. So hopefully this was useful, and thank you for your time.